Well, good day. This video is a little intro to chapter 6. We're going to talk about distributions, different shapes of distributions. So I've got kind of two examples here to kind of introduce you to the concepts we're going to study. Fairly simple situation. Suppose you roll a four-sided die. Show the probability distribution of outcomes. And again, this is not too complicated. There's only four outcomes, 1, 2, 3, 4, and each has the exact same chance of happening. So in other words, each one has a 25% chance of happening, and that would be a probability distribution of all the outcomes. Now, building on that, we kind of can say, all right, well, we can kind of picture this. It's kind of, we'd have a bar graph or a histogram, if you will, where, okay, here are the outcomes, all the ones are here, all the twos, all the threes, all the fours, and they all happen about 25% of the time in the long run. But two of the questions we're going to look at in this chapter are, what is the expected value? Really, this is just a question of mean. What's going to be kind of the average roll that we get in the long run? But we're going to use that phrase, expected value. What can we expect to get on each roll? And so the mean will be the expected value. And the other question we're going to ask about is, what is the variance? Now, in the past, we've been using this idea of standard deviation, and you hopefully recall that really, just the square of standard deviation, that's what we call the variance. So I'm going to go through and work this out with you a little bit. Now, some of this is going to seem like review, but there's going to be a little bit of a twist on here. So in order to find out what the average would be, and I think everyone in the room can kind of tell, well, the average is going to be right here, right between 2 and 3. It's probably about 2.5 is probably the expected value. But let's see if we can get that through calculation. Okay, so in the past, what we've had is we've had outcome and we've had frequency. Well, now we have probability. We actually have proportions here rather than kind of integer values here for frequency. So we're going to go through and work this out as we have in the past. We're going to say, well, what's the value of all this? Well, a 1, which happens 25% of the time, that would be worth 0.25. And a 2 that happens 25% of the time, well, if we multiply, that would be 0.50. 3, which happens 25% of the time, that would be worth 0.75. And then 4 times that would be worth a 1. And so when we add up all of these values, we're going to have, let's see, that makes 1, this makes 1. We end up getting 2.5, which is the mean, or what we call the expected value. Okay, so sometimes you'll see the text will call it E of x for the expected value, and x happens to be the outcome on that. So it's pretty straightforward. Notice one thing we didn't do, though. We didn't do any division this time. And that's because division's already been done here with the probability. So now let's look at, well, how do things deviate from the average? So we have an outcome of 1. Well, that's 1.5 below the average or expected roll. We have a 2, which is 0.5 below. 3, which would be 0.5 above. And 4, which would be 1.5 above. And those would be the deviations. And as we see here, well, 2.5 is in the middle, so the positive and negative deviations kind of balance out or cancel out. So we're now going to square the deviations. And so let's see, 1.5 squared, I think that's 2.25. I'm just going to double check that. Yeah, that'd be 2.25, and then this would also be 2.25, and then 0.5 squared should be 0.25 and 0.25. But of course we've got to figure out the value of all of these. Well, now in this case, everything happens 25% of the time. So 2.25 times 0.25 would be about 5625. And then this one down on the bottom would also have to be 0.5625. And then right here I'd be multiplying this 0.25 times 25% of the time. 0.25 times 0.25. I think that's, yeah, 0.0625. And that would happen in both of these places right here. And so of course then we add up all these values together. So 0.5625 plus 0.0625. I'm just going to go double that. And so I end up getting about a 1.25. And again, we don't do any division here. There's no dividing by n minus 1. And that's because we don't have frequencies anymore. We have proportions. The division has already occurred in making these proportions. So this is what we're going to refer to as the variance. And then, of course, if we square root that value, root 1.25, we get the standard deviation. And that's our symbol for standard deviation, about 1.118. Now, sometimes we call this sigma squared for the variation. And so there we have the kind of the summary statistics for this. Now, you can actually do this on your calculator as well. I'd like to show you how that works. So I'm going to go to Stat, I'm going to edit. Okay, so let me go ahead and clear these lists out. Here and clear. Okay, so let me put in my values. So I've got an outcome of 1, 2, 3, 4. And then over here I've got my frequencies of 0.25 in each case. Okay, so I've got my outcome list and my frequency, or in this case my probability list. So now I'm going to go to value&var stats, and I'm going to calculate and do value&var stats. Okay, so my outcome list is list 1, my frequency list, which happens to be my probability list, is list number 2, and then we're going to go down to calculate, and this looks pretty familiar. You see that the average 2.5 like we got by hand, but you'll notice there is no SX this time. Okay? In the past, when we had frequencies here, we were getting SX. Now we don't get that. All we get is sigma x, which is the population deviation, 1.118. So that's one thing to note, is when you work with probabilities rather than frequencies, which are integer values, you're not going to have an SX. You're going to actually have sigma x right here. So expected value 2.5, and then this would be the deviation. And of course, if you square that, then you would get the variance right here, 1.25. Okay, so that's one example. Let's take another example, something a little more complicated. Suppose you roll 2 4-sided dice and record their sum. Show the probability distribution of the outcomes. Okay, so this time it gets a little more involved because now we're looking at sums. So again, you may want to make a sample space, or kind of picture a sample space in your mind and say, well, okay, there's one way to get a sum of 2, there's 2 ways to get a sum of 3, 3 ways to get a sum of 4, and so on. So out of the 16 rolls, okay, I have a 1 in 16 chance of getting 2. I have a 2 in 16 chance, or 1/8, of getting 3. I have a 3 in 16 chance of getting a 4. I have a 4 in 16 chance of getting 5. Let's see, I would have a, for 5, yep, and then it's going to go back down. 3 out of 16, 2 out of 16, and then 1 out of 16. So you have kind of this sort of pyramid or triangle pattern in the distribution. And so we're now going to answer the questions, well, what's the expected value or the mean? Well, it certainly looks like it's right there between 5 and 6, maybe about 5.5. And then we're going to try to get the deviation. Now, keep in mind, this is not a normal curve. It's getting there, but a normal curve is like a lot more of its density in the middle than this one does. This one's a little too thick on the tails to be considered a normal curve. So this time I'm going to use the calculator to get the statistics. So let me go back to my lists, and I'll just go ahead and type over these. So 2, 3, 4, 5, 6, 7, oops, and 8. And then we'll go to the other side, and now you can actually put fractions here as well. So if I just do 1 divided by 16, it'll convert it for me. 2 divided by 16, 3 divided by 16, 4 divided by 16, 3 divided by 16, 2 divided by 16, and 1 divided by 16. And so there I have my probabilities to go along with my outcomes. And so now once again I'll go stat, slide over to var stats, and let's see, list 1 is my outcomes, list 2 is my frequencies, or in this case probabilities. Slide down to calculate. And so, okay, so this time, so the average is a 5, the expected value is a 5, and then the deviation is about a 1.581. So I'm going to go ahead and record those over here. The expected value, or if we use the symbol mu, the population average or expected value is a 5, and then the deviation about a 1.581. Now, of course, if I square that, okay, 1.581 squared, I would then get sigma squared, which is also known as the variance, of about a it says 2.4995, so I would probably round that to about a 2.50 for the variance on here. And so that's how you calculate. Now, one thing I want you to kind of notice that's going to be important as we go through this is notice that the variance here is twice as much as the variance here. And that is no accident. We're going to be, you'll be reading about a property of variances that'll kind of make more clear, way to phrase it, but why we see this kind of relationship in the variances. This is why variance is so important. You see a lot of interesting relationships when you look at variance. You don't really see that same relationship when you look at the standard deviations. So that wraps it up for this video, and I will talk to you soon.